Write each of the given numbers in the polar form, r to the ei theta. I think most people call this the Euler form, but it's okay. It's really just asking for the magnitude or the absolute value of z, or the length of z, and then the theta, angle theta, which is also called the argument of z. Okay, the first one is just this De Moivre's theorem, which says r theta to the nth power is r to the nth power and theta, which is called De Moivre's theorem or formula. Now, because this r angle theta is just a shorthand for r cosine theta plus I sine theta, the nth power of this, saying that this is equal to this right side, really means the following. And this applied here simply means that since r is 1, you don't have any r, it's just this cosine is I sine theta. This formula applied here simply means that you get cosine of 2 pi over 9 times 3 plus I times sine of 2 pi over 9 times 3. And because the r value is still 1 here, you should think of this as r value of 1, your angle would be, your length of r will still be 1, whereas this one would be 2 pi over 9. 3 and 9 cancel, so it's 2 pi over 3. That's the angle. So that part is easy. Okay, what about 6 plus 6i and minus radical 3 plus I? Well, you can first apply, how do you divide two complex numbers? You multiply the conjugate of this number, top and bottom, right? So you can multiply negative radical 3 minus I on the top, and then, oh, I just realized something. This is not going to work very well. Let's see. Let's use a different strategy, because it's better if you change both top and bottom separately as polar form, because if you have both as polar form, then dividing two polar forms, the magnitudes divide, whereas the angles subtract. So using this formula, you can get the final answer. Alright, now I'm saying this because 6 plus 6i is easily drawn. It's 6 and 6i, and it's like this. And this angle would be 45 degrees because it's an isosceles right triangle, right? These two lengths are the same. And this length here would be square root of 6 squared plus 6 squared. And that would be 6 times radical 2. So the top one, 6 plus 6i, can be replaced as 6 radical 2 and then angle of 45 degrees. On the other hand, if you have the negative radical 3 and then I, and see, this is like, you know that these are special lengths of a 30, 90, 60 triangle, 30, 90, and 60 degree triangle. So since this is the sharper one, this would be 30 degrees, meaning that this would be 150 degrees. So you know that this number in downstairs would have the angle of 150 degrees. But on the other hand, you need to find the distance, and because this length is radical 3 and this is 1, by the Pythagorean theorem, you have to do 1 squared plus radical 3 squared, which is square root of 4, which is 2. So this would be 2. And therefore, now if you divide them using this formula, you're going to get 6 radical 2 divided by 2, angle of 45 degrees minus 150 degrees, and that's going to be 3 radical 2 and then negative 105 degrees. Okay. Now you have to make sure that this angle is true. This angle is within these bounds because theta is between negative 180 degrees to positive 180 degrees, so this is okay, right? And then 105 degrees, if you change this into radians, because it has to be in radians, I should multiply by pi and divide by 180. And if you divide top and bottom by 5, that's 5 times 3, 36 down here, and then 221. Oh, you can still divide by 3, so it will be 7 pi over 12. Okay, so that's going to be the answer, 7 pi over 12. And then 3 radical 2 would be actually minus 7 pi over 12. Let's be careful. And 3 radical 2 will be the length r. Okay. Now let's see. 4i would be, well, it's too messy, so let's write this somewhere. 4i over 5 e to the 8 plus I. And this is really, you can rewrite I as e to the pi I. No, that's not true. Pi over 2i, right? Because I itself is 1 angle 90 degrees, which is 1 angle pi over 2. And using the identity that r angle theta is r times e to the I theta, you can rewrite this as 1 times e to the pi over 2i. And then now I have 4 in the front, so you have 4 e to the pi over 2i divided by 5 e to the, I want to break this as e to the 8 times e to the I. And then see, you want to put the real parts together because this part is r, 4 over 5 e to the 8, times, when you divide the exponents they subtract, so this is pi over 2 minus 1 times I. And since this is true, your r would be this value, r and r, and angle theta is what's after I, so it's this one. So the answer would be 4 over 5 e to the 8 as your r value, and your theta will be pi over 2 minus 1. Make sure your angle is between negative pi to pi. Here, pi is 3 point something, so if you divide it's 1 point something. So if you subtract 1, it's still positive and it's less than pi, so this is indeed, it satisfies this inequality. So that's all.